Hey guys. All right, so we are going to look at just reviewing properties of logs today. I know how you feel about logs. But before we do that, take a moment if you haven't already, pause the video, here are all the trig TTKs, make sure you have a card for each of these. It is very important that you learn these, okay? So press pause, okay. Now we're moving on. So just a review today of properties of logs, because these are very important for when we take derivatives of exponents and logs. It's important that you understand how and why logs work the way that they do. So the important thing to keep in mind is that a log function, a logarithmic function, is just the inverse of an exponential function. And when we say inverse in math, it just means they cancel each other out because one is the opposite of the other. It's like an exponent in reverse. So like subtraction cancels out addition and multiplication cancels out division and logs cancel out exponents. Okay, so if we start with saying that some base b is being raised to a power p and the output is some number n, that's an exponential. And if we rewrite that as a log, it becomes this. Log base b of n equals p. So stuff moved around, but it's not just that it moved around. The output of the function is different now. So b is the base of the exponential function, okay? That's the base of the exponent in the beginning on the left. Now the power, though, is the output. So instead of plugging in a power and getting out a number, now you're plugging in a number and getting out the power that would have given you that number, because it's backwards. So the output of the exponential function is now the input of the log. So you can think of it this way. To what power do you raise b in order to get n out? So with that in mind, if we have log base b of b, in other words, those two values are the same, like if you have log base 10 of 10, or the natural log of e, okay? Log base b of b is just equal to 1. Again, it's easier if you think of it as an exponential backwards, because b to the first equals b. So you're saying, okay, what power do I need here? Well, the power that you need is the first power. Okay, moving on. Log base b of 1, again, think about 1 is the outcome. You're saying b raised to a power equals 1. Well, we know that everything raised to the 0 power equals 1, so this is just equal to 0. Because b to the 0 equals 1, that means log base b of 1 equals 0. All right, log base b of x. So here what you are saying is b raised to what power? You're saying b raised to a power equals b to the x. Well, it's the x power. So that x power is the output. Okay? So it's just equal to x. You can think of it as those b's canceling out because you have an exponential function inside a log. So that's another way to think about it, because logs and exponents cancel out just like addition and subtraction cancel out. That's right too. Log base b of x times y. Okay, so for this, think about exponent properties. So if you have b to the x times b to the y, the shortcut is that you could just add those powers together. Because, for example, if you have b squared times b to the third, you have b times b from that b squared times 3b's from the b cubed, and you end up just being able to add the exponents. So because that rule works that way, we can then go the opposite direction and say, well, log base b of x times y equals the sum of the logs. Again, because the output of the logs are powers, and you're adding the powers. This works for quotients and differences too. Log base b of x over y, you can separate the quotient inside the log to a difference outside the log, because that rule works for powers. Because if you have, for example, like b to the 5th over b squared, and you have 5b's over 2b's, you get the idea. Right? You can cancel out, and it ends up just being the same as the difference of 5 minus 2 is 3. Okay? So because that works, it works the opposite direction with logs. If you have a quotient inside the log, you can turn it into a difference outside because the powers are being subtracted and the output of a log is a power. Okay? Last one. If there is a power inside your log and the base is something other than b, like if it's x squared or x to whatever power, you can take this power out because the output of the log is another power and you're multiplying those powers together. Okay, so you can watch this video as many times as you want. And if you're still not clear on it, guess what? Google is your friend. And you've done all of this before. None of this is new. That's why it's called review. So make sure you are comfortable with all of these log properties. And another thing to keep in mind, whenever it's ln, we call that the natural log, because you sound silly if you just keep saying ln, 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 say natural log. But a thing to keep in mind is that the natural log is the same thing, let's say natural log of x, is the same thing as saying log base e. That's all natural log means. So if, for example, you're doing the natural log of e, that's like you're saying the natural log, or rather the log base e of e, and you're saying, really you're saying e raised to what power gives you e? Well, it's the first power. So that's why the natural log of e is just equal to 1. So make sure you're comfortable with all these properties. Make sure you've got all this down. Any of them that you're not comfortable with, consider it a TTK and make sure you just get that into your head. Okay.